So today we're going to do section 6.4, and our purpose statements is to be able to sequence a step to factor polynomials. Now we have already factored polynomials, but all those were when we had a quadratic. And so now we're going to look at how we can factor things that aren't quadratic. A lot of the rules are still the same, like you still want to put it in order from highest to lowest, you still want to look for greatest common factor. But now we won't use the X method, as we'll look at other things. And today we're going to look at some special cases for factoring. So, the first thing is the factor theorem. And the factor theorem is simply for any polynomial p of x, x minus a is a factor of the polynomial p of x, if and only if. Now, IFF is an abbreviation for if and only if. You should have used if and only if statements in geometry when you had some of the theorems that if it works both ways. So this is the case where it works both ways. If it's a factor, then p of a will be 0, and if p of a is 0, then you know that x minus a is a factor. So that allows us to just check. And so part of the assignment is going to be just checking to see. They're going to give you a polynomial. Let's say f of x equals 4x cubed minus 5x squared plus 2x minus 3. And they're going to ask you, is x minus 3 a factor of this? So does it go into that evenly? So we're going to use our stuff from the last section and use synthetic division to find out. So remember, with synthetic division, we do the opposite of this. We do 3. We put the coefficients in, 4, negative 5, 2, negative 3, and then we do the synthetic division. So we bring down the 4. 3 times 4 is 12. We add, so we get 7. 7 times 3 is 21. Add 23. 3 times 23 is 69, and so we get 66. If, remember this last number is our remainder, if that remainder is 0, then it would be yes, it is a factor. In this case, x3 does not go in, so x minus 3 would not be a factor of that. So you're just going to put yes or no on these. Yes, it is a factor, or no, it isn't. So, another example. X plus 1. Is x plus 1 a factor of this? So again, we just have to take the opposite of this, negative 1, and then put our coefficients. Down. Now remember, if it ever skips a power, you have to put a 0 in. So we bring down the 2. Negative 1 times 2 is negative 2. So we get 0, 0, negative 1, 1, negative 4, negative 1 times 4 is 4. Our remainder is 0, so the answer would be yes, it is a factor. So you just do the synthetic division. If your remainder is 0, then it's yes, it is a factor. If it's not 0, then it's no, it's not. So I'd like you to try this one. This goes on our half sheet. So you try this. You can pause the video here and then check, and I'll put it up here so you can see if you did it right. So remember, we put down the opposite of this, so you should have put 2, and then 5, 1. Now remember, there is no x to the first power, so I have to put a 0 here. That's the most common mistake people make, is if it skips a power, they don't remember to put a 0 up. So we bring down the 5, that would be 10, 11, 22, 22, 44, 35, and so the answer would be no, it is not a factor. So hopefully that makes sense. You just use the synthetic division. Now, the special situations of factoring, and this is what most of the assignment is. We're going to look at some special cases that we have rules for factoring. Some of these we've used before, some are new. So the first thing is, if there are more than 3 terms, we should factor by grouping. So as an example, if we had 4x to the third plus 4x squared plus 5x plus 5. We have more than 3 terms. Again, the first thing I should check for is the greatest common factor, which this doesn't have. But what I want to do, normally you just can try grouping the first 2 and the last 2. That's what I would always try. Sometimes you can rearrange the order in helps, but I think everything you'll have, you can do this way. And so then we pull out the greatest common factor. So both of those have a 4x squared. And then we get, this would be x plus 1. And now we pull out the greatest common factor here, which would just be 5. And again, we get x plus 1. So most people don't have a problem with this step. The next step is actually the exact same thing. We're now going to use this whole thing, and we're going to look for a greatest common factor. We went from 4 terms down to 2 terms. So now both of these have an x plus 1. So because they both have an x plus 1, I pull an x plus 1 out. And then what do I have to multiply this by to get back to this? Well, I have the x plus 1, I need to multiply it by 4x squared. And I need to multiply this one by 5. Because if I did, I would get 4x squared times this, which would be this term, and 5 times x plus 1, which would be this term. And now we've got it completely factored. Now when you get to here, you should always, anytime you have an x squared, you should check to see, is it possible to factor that any further? In this case, it's not. There aren't, you could use the x method, but there are no factors of 5 that add up, or 5 and 4, so 20, that add up to give you the middle term of 0. So we would be done here, and that would be factored completely. So when you have more than 3 terms, we want to factor by grouping. The next case we're going to look at is the sum of 2 cubes. This is when we have anything like this where it's a cubed plus b cubed. Okay? And that factors into a plus b times a squared minus ab plus b squared. Now the problem is it won't always look like this. Like it could be something like this. 16 x, let's go x cubed plus 250. And that doesn't look like it's the same thing. But remember, we should always check for a greatest common factor. And in this case, 2 goes into everything, so I can pull a 2 out front. And then I get 8x cubed plus 125. The giveaway for this is when you have cubes, you always want to check to see if this fits. So the question to ask yourself is there a perfect cube for 8, and is there a perfect cube for 125? So what I'm going to do is I'm going to rewrite this. I've still got this 2, but I'm going to write 8 as 2x cubed. 2 cubed is 8, x cubed. And I can write 125 as 5 cubed. So now in this case, our a is 2x, and our b is 5. The 2 out front just stays there, and so it becomes a plus b. So our a is 2x, and our b is 5. And then a squared, so 2x squared would be 4x squared. 2x times 2x. Minus a times b, so 2x times 5, which would be 10x. And then plus b squared, so 5 squared is 25. Now for some of you, a helpful thing to do might just be to write down, in this case our a is 2x, and our b is 5. And then you just plug it into the formula. Now with the difference of 2 cubes, it's really the exact same thing, except this is a cubed minus b cubed. And then our formula is a minus b, and then a squared plus ab plus b squared. So we could do this whole problem exactly the same way. This would just be a minus here, which makes it a minus here. And a minus here. Our a is still 2x and our b is still 5. This just becomes 2x minus 5y, and this becomes 4x squared plus 10x plus 25. Because nothing changed except, as you can see with the rule, instead of a plus b, it's a minus b when this is a minus sign. And this is a minus here, and it becomes a plus in this one. So the work is exactly the same. It's just the difference between the sum of two cubes and the difference of two cubes. A perfect square, we worked with this. This is all the work we did when we went through completing the square, was to get it in this form. So you just have to be able to recognize that this middle term is twice the square root of those added together. Now, the thing is, when a perfect square, you can always use the shortcut, but you don't have to. We could still use the x method. So as an example, if I did, let's go plus 25, and so that would be 2. That would be a case. A lot of people don't recognize that this is in that form. The thing you just want to check for is, does it work? The square root of 4x squared would be 2x. The square root of 25 is 5. If I multiply that, 2x times 5, I get 10x. And if I double it, that gives me the middle term. So I know it's in this form, so I can just put 2x plus 5 squared, which is the same as 2x plus 5 times 2x plus 5, but we'll just write it like this. Now, the thing is, if you don't recognize that, we can still use the x method. 4 times 25 is 100. B is 20. The numbers that multiply together to give you 100 and add up to 10 are 10, or add up to 20 are 10 and 10. We can now build our box. Remember, your first term goes here, your last term goes there. Then we have 10x and 10x. Greatest common factor of 4 and 10 is 2, and we have an x. Greatest common factor of 10 and 25 is 5. The first box is positive, so 2x plus 5. Again, we get a 2x here. We get a 5 here. It's positive. So we get the same thing. The shortcut just saves you time, but you can always go back to that x method and it will work. So you don't have to really recognize that that's in that form. So that would be if it's a perfect square. The next one would be the difference of two squares. And again, we have worked with this one before. This one is kind of nice to have the shortcut because it's so fast. So if we had like 9x squared minus, let's go 49. Okay? It's nice to be able to recognize that when if I can take the square root of both, it just means the signs are opposite. So since I can take the square root of 9x squared, that's 3x. And I can take the square root of 49, that's 7. So it's 3x plus 7 and 3x minus 7. Now again, you can use the x method on this. You're still going to get the same answer. If I do the x method, I go a times c, so 49 times 9, 441. And then I get my middle term, there is no b, so it's 0. So what's nice about this, and this is a negative 441, the only way I can get these to multiply to give me this and add up to zeros if they're the same, so you just take the square root of both sides, which would be negative 21 and positive 21. And then you can build your box. 9x squared, negative 49, negative 21, positive 21, x is with that. Greatest common factor is 3x, 7, positive, 3x, 7, first box is negative. So again, you get the same factors. Again, it's just if you can recognize that this is one of the shortcuts, it saves a lot of time. I don't have to go through this whole process. So you just check if it's a minus. And as you do this, you're going to be dealing with one of these shortcuts on the whole assignment. And so, the thing to ask yourself, is it a square? Is it a cube? If it's 3 terms, check to see if it's a perfect square. That will save you some time from doing the X method on some of those. And again, the cubes you have to do using the shortcuts. So, got some examples here that we'll go through. So you just want to go through and say, does this meet any of the criteria? So on this one, the first thing I should always check for is greatest common factor. So I can pull a 2 out. And then I get x cubed minus x squared minus 4x plus 4. The next thing, how many terms do we have? It's more than 3, so let's do this, look at grouping this. So I'm going to group the first 2. Now with a minus sign, I'm just going to put a plus between here and group these. The 2 I'm going to forget about, we'll bring that back in at the end. So I take out my greatest common factor, x squared. Now let's go ahead and put that 2 back in there. Actually, no, let's leave that 2 out until the end. So I get x squared, and then if I divide those both by x squared, I get x minus 1. Remember, some people drop this when it's the same. You have to multiply by -1 to get there. Now I want this to be x minus 1. So these both have a 4. If I pull out a positive 4, I get negative x plus 1. So I'm going to pull out a negative 4. And that gives me x plus 1. The key with, x minus 1. The key with grouping is you want these to end up being the same. Because then you can pull an x minus 1 out of both those. And so this becomes x squared. So then I can pull an x minus 1 out of both those. So I get x minus 1. And then whatever's in front of that goes in the next one. So I have the x squared minus 4. We still have that 2. Then when you get to here, anytime you have a power to the second, you want to see, can I factor that any further? And we have an x squared minus 4. Does that fit any of our shortcuts? And it does. It fits this one because they're both, I can take the square root of them. So this factors into 2, x minus 1, and then the x squared minus 4 factors into x plus 2 times x minus 2. And we factored that completely. Now what we're leading up to is later on in this chapter, we're going to be able to find the zeros with the roots. And this will get us to where, like if this was set equal to 0, we know that one answer is 1, negative 2, and positive 2 would be our answers. So that's one. Let's take a look at another one. So let's do this one. In this case, there is no greatest common factor. So I'm going to group it. So I can pull a x squared out of that. And I get 2x minus 3. Now, this is negative 2x plus 3. I want a positive 2x minus 3, so I'm going to pull a negative 1 out to change all those signs. If it was already 2x minus 3, you just want to pull out a plus 1. You always have to have that number in front. So now I get 2x minus 3. Now again, I'm looking for what's the same in both of these. So then I pull out a 2x minus 3, and then I put what's in front, x squared minus 1. Again, since it's an x squared, I ask myself, can I factor it further? Is the difference of 2 squares? Yes. And so that factors into 2x minus 3, and then x plus 1, and x minus 1. So you have to be careful that you factor it all the way. Anytime you have a squared left, I would always check to see if it goes any further. So, that's an example of grouping those two. Now let's look at a couple other examples. So you have to decide, this is 8 minus m to the 6. We have to decide, does it fit any of the rules, the special cases? Well, it's not more than 3 terms. The sum of 2 cubes, 8 is a cube, m to the 6 I can write as a cube, but it's not the sum, so it is the difference of 2 cubes. So what I'm going to do is use this rule here. And in this case, my a, 8, what cube gives me 8, which would be 2 cubed. And then what cube gives me m to the 6th? And so that would be m squared cubed, because remember, you multiply the powers. So in this case, my a is 2, and my b is m squared. And so now I plug it into the formula, and it becomes 2 minus m squared, and then a squared, which would be 4, plus a times b, which would be 2m squared, and then plus m squared squared, so now that would be m squared to the 2nd power, so m to the 4th. And we're done. We factored that all the way. These are m squared, but I can take the square root of m squared, I can't take the square root of 2. And this one doesn't factor any further. So we're done. That would be our answer. So let's take a look at this one. So again, the first thing we should always look for is greatest common factor. I can pull a 4 out and a t squared. And so I get t to the 3rd minus 8. Then I want to know, does that fit any of my rules? It's to the 3rd power, so that's cubed. 8 can be cubed, so in this case my a is t, my b is 2, and so the 4t squared stays the same, and then we just go a minus b, so t minus 2, and then a squared, so t squared, plus a times 2, which would be 2t, plus b squared, which would be 4. And we're done. So, like you, try these two. So if you'll pause the video here and try these, and then I'll do them while you're doing that, and you can check back. So what we do here is we check what rule it fits. It's not more than 3 terms. This is a cube, and 27 is a cube. That could be written as 3 cubed. So I'm going to use my rule for cubes, which says a cubed plus b cubed is equal to a plus b, and then a squared minus ab plus b squared. So my a in this case is 3. So 3 plus my b is x, and then a squared would be 9 minus 3 times x plus x squared, and I'm done. All right? The other example over here, it's more than 3 terms, so I'm going to group it. Again, I put that plus sign there. So a greatest common factor would be 3p squared, and then I get a p minus 7, dividing those both by 3p squared. And then over here, again, I want this to be p minus 7, and it's negative p plus 7, so I'm going to pull out a negative 1. That gives me p minus 7. Greatest common factor of these two, they both have a p minus 7, so I pull that out front. And then 3p squared minus 1 from this part. Again, check. This is a square minus 1, but 3 is not a perfect square. 1 is, so I'm finished. That's as far as I can go. So your assignment for today, page 433, 17 to 43, the odds. You can skip number 39. Remember, the key is to go and look and see. Some of it's going to be just using the synthetic division. The first thing we did. Do the synthetic division. If it gives you a remainder of 0, it's yes. If it's not, it's no. And then the other is going to be trying to decide which special situation of factoring we have so we can factor those completely. So make sure you use your notes, compare it to the formulas you have to use, and good luck on that.